Hello. Today I would like to show you how you could create a marble pattern like this I show in this display. The marble pattern is like a contour line patterns applied on any free surface, and this time I'm using a UV to draw this as a texture, applying a texture on the surface by modifying the UV, and because of that you can animate the UV like this, create a marble animation like these. You could also offset some surface like a wavy pattern like these. So you can create like pretty interesting effect using this method, using this technique. So that's what I want to show you. That's what I want to share with you guys today. Now, before getting into the detail, the same modeling pattern is also explained in this book that I wrote recently called Algorithmic Design Workbook with Houdini. It's a practice book, a workbook for Houdini for people who is a beginner or intermediate at Houdini's procedural modeling. And I have created like 21 questions with 2 sample answers that you can refer to. And the last questions is called surface modeling, and it's pretty much the same thing as this one. The visual itself is pretty similar, but the method explained in this book is different from what I'm going to show you today. So if you're interested in the other method, then please consider buying this book. It's $15 if you're interested. Yeah. Okay. Now, let's start creating a Houdini file for this modeling surface. Now, before getting into the practice, let's look at some algorithm that I'm gonna use today. So first you have this kind of free surface, could be really a random surface. You can also like a pig head or something like that. And you first pick a starting point on the surface. Then what you want to make is a surface contour which starts from the starting point, gradually grows based on the curvatures of the surface like this. And the point here is that the distance between those contours is always the same. So if you have like distance called D from the first contours and the second contours, then the distance at this point have also the same distance with this one. So this D is always the same. Same for the other contours. When you look at the distance at here, if it's D2, then the distance here is also D2 because it's on the same contours. So that's the rule here. Now, in order to create something like this, what you need to do is, the easiest way that I found out is to first get like random points other than the starting points on the surface like these, and for each of those points from the starting point, calculate a shortest path. So something like this from the starting point to the end point, and do the same things for each other points. And by doing this, you can determine the shortest path on the surface, and you can, by having this curve, you can also calculate the distance of this path. And by applying this distance as an attribute to a endpoint, you can determine, or you can guess that if you have the close value of distance, then that means that you have the contours line like this. So any points which is on this contour line should have the same distance. Like this. Everything is equal. Like this one, and this one should be equal when the contour line is where the contour line should appear or should exist. Same for the other contours. If you're looking into this one, then the distance at these points on these contours should have the same distance. So this one, this one, this one, this one. Now, keep that in mind. So all you need to do here is to calculate the shortest path and the distance between the starting point and the other random points. And luckily enough, we have a shortest path node inside Houdini, so you can easily calculate the distance from the starting point to the end point. Now, in order to do that, we have to use kind of a for loop. So the initial setup might be a bit slow, but after you have determined the value, the distance, then you can convert this. You can map this distance value to something like a UV information to use it for texture mapping, which you can animate later. So that's what I want to do today. So let's start. Okay. So you have geometry node and getting into it. Let's start by creating a null node named controller to have parameters that you want to control. Okay, and I will start by creating a random surface. So I'll just use the meta ball this time, because it's kind of an easy way to create a random surface. So let's create a sphere first, single sphere, and make a volume out of it from using ISO offset, and use the scatter points to place some points, maybe 10 points, right? And create a meta ball and copy this meta ball to this point to create a kind of random surface like this. Okay, interesting enough. Now this itself is still a meta ball, it's not polygon, so let's convert it into polygon using convert. Oops. And I seem to have an error here. Okay. And set the U to some high numbers like 10 so that the geometry will be smooth. Okay. Now I also want to change this shape later on to try out different geometries, different shapes. So let's make one parameter called seed in order to change the shapes from this scatter. So I want to control this global seed. By changing this, I think you can create a random surface like these. So The easiest way to promote this into the controller, you can first click this gear, check this 4-bit linking parameters from outside the subnet, then drag and drop this global seed to a existing parameters like this. Okay, and apply, and you'll have this global seed parameters promoted inside this null controller. Okay, great. Now next thing, let's right now this surface is pretty dense or pretty high res, and it could be a problematic in order to use a shortest pass because you have too many points here, and the calculation of shortest pass is a bit expensive and you have to use it inside a for each loop. So I would like to reduce the number of calculations at this point. So let's do a remesh to reduce the number of meshes. And let's say right now the target size is 0.2, so I'll just go with this. Became a bit low res here, but and it'll be fine later on because I'm gonna use some smooth function to make a smooth UV. Okay, now after you have made this low res, what I want to do next is to create this shortest pass from a point that you decide on the surface to the other points. Okay, now so let's start by creating a starting point on this geometry, and I am just gonna pick a point of the vertex. I'm just gonna pick one of the points used as a vertex here, vertex of the polygon here. You can also use scatter points, but either way it's fine. Okay, so I'm gonna use the attribute wrangle, and I'll set the points run over to detail, and I'll name this set start. Okay, now first get the number of points by endpoints, and get the random point index using npt times random value rand. So I guess I want to also randomize the starting point, be controllable. So let's make another seed parameter here, and you get the random index for the points. And for this point, I'm gonna apply a group to determine that this is a starting point. I'm gonna name it start, and at this random index point 1. Okay, now let's check by deleting the starting point. To see if you have random position. Okay, I don't see. Okay, I think I have to make this floor to make it as an integer, and I still don't see a starting point. Let's check. inspector geometries, and yeah, I think I should have one point here. Okay, delete unselected. Okay, I don't see it. Let's go back. Start. That is weird. Wait. Oh, okay. I was setting as an attribute, not group, so I have to set point group. Okay, my bad. Okay, now I should be able to get the start like this, and by changing the seed I can pick the random starting points. Okay, let's also promote this inside the null controller. Go back to the set start and drag and drop this seed. Okay. Uncheck this. Drag and drop this seed. Let's rename this. So the first one, I'll rename this to shape seed. The second one, I'll rename this as a start seed. Right. So I have two random seed. Okay. Right. Now I have got the starting point. Let's calculate the shortest distance for other points on this surface. So what I'm gonna do is to use a for each point, connect it to here, and I do want to look at each point, but I don't want to feedback the point itself, but I just want to feedback the geometry, the surface, and apply the distance value to each point of the geometry. So I gotta change this gather method to a feedback each iterations, and for the for each begin, apply change this to fetch feedback. Now this one will loop the number of points for which construct the geometries. At this point, for mine, it's like 702. And so it's gonna loop like 700 times, being feedback for a number of points. Now, I do want to have a meta node to get the iterations information, like for the loop, and let's start by setting a end group for each point. Now I'm gonna use the for each wrangles and connected the first feedback geometries to the first input and the meta node to the second. And first I'm gonna get the iteration from the detail from the meta node, which shows which iterations you're in this loop. And by making a condition, maybe it will be easier. Maybe you don't have to use a point wrangle, but just detail is fine, because I just want to set one point for each loop to set as an end, because the shortest path node only works for one point, the one set of points, like start and end. So I just need, for this one loop, for each loop I just have to set one end group. So by setting the detail, I'm gonna again set the point group named as an end at the iteration position, iteration index as 1. Okay, set end. Oops, what's this? Okay, let's check. Go to the geometry spreadsheet and look at the point, and if you have one end, that's fine. Now, here comes the find shortest path node, which you can use to create a shortest path from the start to end on a specific geometry. So just connect this geometry which has a points grouped as start and end, and look at the geometry and look at the parameters of this find shortest path, and you can set the starting points and end points group here. So let's set the starting points to this one and end points to this one, and as a result you will get, okay, let's go back, you will get the path like this, which is a shortest path from the starting point to the end point on this geometry. Now, as you can see, because I am using the row res geometry here, it's a bit jaggy. The curve itself, the shortest path itself, is a bit jaggy. So let's smooth it out a little bit by, first of all, maybe do some resampling and convert it, change this to subdivision curve or something. Okay, and make a division like 0.25 or something like this, maybe a little bit lower. Maybe 1. Okay, subdivision might be better. And after this, I'm gonna also use the smooth to smooth out this a little bit more. Maybe like 30 iterations. Yeah. Now this is smoothed out. And let's go back to see the geometry, the base geometry. Yeah. Looks pretty clean right now. Then what I want to do next is to calculate the distance, or calculate the length of this path and use it as a distance, and which can be converted into UV value later on. So that is easy. Just use measure node to get the parameter like this, and you will get the length of this curve at this primitive wrangle as a perimeter. Okay. Now that you have this perimeter, the length of the curve or the distance, what you want to do next is to apply that value to the point that you have picked as an end in this base surface. So the point that you want to apply the attributes does have a group called end, so I'm just going to use a point wrangle again and connect it to the first input, and this one to the second input, the measures with the parameter value to the second input, and I'll name this to apply attribute, and let's set the group, filter the group to end, and it's pretty easy. Just set the distance attribute with the length value, which is contained in this measure node. Okay, let's check. So if you look at the end group of the point, then you have this distance, and that looks good. Now, after you have applied this, let's delete. You need to delete the end group, because on the next loop you want to apply the other end group to the other point. So delete the end, and let's check if you have, okay, you have deleted the end group, and that looks fine, and connect it to the for each end, and that will continue until it loops through all the points, the geometries, and after that you will get each point with the distance from the starting point inside each point primitive, inside each point rank attribute. And as you can see, the distance 0 is at the starting point, which is correct. Okay. Now after that, it is pretty straightforward, and you just have to convert this distance value to some value that you want to use, like a UV, to modify or create some interesting animations or interesting patterns. Right. Now before doing that, as you can see, the geometry itself is a bit too low res in order to create some interesting animations or interesting patterns. So let's make it a bit high res using Remesh with some low target size, maybe 0.02. Now this might take a while, and as you can see, after you have remeshed the low res to high res, you can kind of see this polygon-like triangles, even if each face is pretty small. And so you have to smooth out a little bit to make it more smooth. And by doing this, you can also smooth out the normal as well, I think. Now 10 is not enough, I think, so let's make it like 50 or something. And let's filter quality to 1. And that seems a bit more smooth. Though by using this smooth node, it kind of loses the original shape. So if this is the original shape, as you can see, the smoothed out shape is a bit different from the original. So to keep the final geometry same as the original, let's just use the ray node and use the original as a guide or collision. And let's go back here and smooth one to the first, and use the minimum distance method to project the smoothed out surface to the original. Now it looks more clean. Now after doing this, what I want to do next is to also smooth out this distance value, which is applied on each point. Currently it is not smoothed out yet because I've just changed the point positions. So in order to smooth out the distance value applied contained inside each point, I can use the attribute blur node to just smooth out the distance attributes. Now, I think I want to make it really high value for blurring iterations, so I'm gonna just set it to 100 and the step size to 1, and that should be fine. Now after doing that, let's look at the geometry spreadsheet, and you have this distance value starting from close to 1 to some value at the end. So starting from 0.26 and to end at 2.8. Now each time you change the shape, these value will be different. So if I change the seed, the shape seed, it takes a bit time. And let's go back again to see the value, distance value. As you can see, the value is a bit different from the last time. So what I would like to do is to get the minimum and the maximum of current distance value first, so that I can remap it to some more useful values. So what I'm gonna use is attribute promote to first get the minimum value out of this distance and apply it to detail and change the promotion method to minimum, and I'll just name it distance min. I don't want to delete the original, and do the same for the maximum. So set it this to maximum, this to max. Okay, now let's check the detail wrangle, detail attributes, and I have minimum, maximum, then that's fine. Now the next thing I want to do is to normalize this distance value. So right now the distance is from 0.2 to something like 2.8. So I want to remap this into the value that I could use in order to use it as a UV or some other values. So now let's create a point wrangle again, and I'll name this to normalize dist normalize. Okay, now let's retrieve the distance minimum and distance maximum that I have just promoted using attribute promotes node, which is contained in the detail dist main. And dist max. Okay. Now, easily enough, the value you can remap this distance value to a 0 to 1 by using a fit function. So the distance which starts from the dist min to dist max, I want to convert it into the range of 0 to 1. Right, and let's update this distance attributes as this value, which goes from 0 to 1. And also let's create some color value that we can use it to update some UV value later on, or the point color itself. So use another fit functions to fit this value, which is from 0 to 1. And this time I am going to use I'm gonna remap to some angle value, which can be calculated by pi times chi, some parameters that I could use, maybe a wave number. This. Okay. So by changing the wave number, the maximum will be pi times 3. And by having this angle, you can use it for a trigonometry like cosine and sine. So I'm gonna add this color. I'm going to use this color as an angle for the cosine function. Now let's also promote this value to as an attribute called col. Okay, now I also want to do some similar stuff for the. I also want to have another value in order to create a wavy surface on top of the surface and on top of this input geometry. So let's just copy these all, and this one I am going to name this wave and do pretty much the same thing here. And for this one I'm just gonna add some additional variable. Okay, I'll name this offset multiplier, and multiply it with the wave num here. Right. Now, other than that, the wave, I'm just gonna have to replace this with wave, and this one as a wave again. Wave and wave. Right. Okay, so in order to make it a bit more interesting, I also want to make some animations here. So inside a cosine, maybe I would want to add some frame value so that it will the sine wave will be, or cosine wave will be animated. And I can also multiply it with the pi. And in order to control the speed, maybe I can add another parameter called speed. Okay, so let's also copy this one and paste it inside here for the wave. And for the additional speed, maybe I could also multiply this offset multiplier. Right, now let's just set some random value here and also promote this each parameters inside null controller again, so that I can control it later on. Like, let's go back here. Okay, uncheck this 4-bit linking. Drag and drop this wave num. Oops. And this speed. And this offset multiplier. Okay. Accept. Now at this point you don't see any differences because I'm just changing the attribute values. In order to see this, in order to see the changes, I need to visualize it using these values. Now before get it into the visualization, I also want to set some UV value for each point so that I can use it for texture mapping. So this time I'm gonna use a vertex wrangle to change the UV for each vertex. Now that first get the point number from the vertex number using the vertex point at VTXNum, right? And get the color information using the point, and using this color value to apply a UV. Pretty simple enough. I'm just gonna use this color as an U value, so like this. Okay, now that should be good. Let's go. Let's check the geometry spreadsheet for the vertices, and each UV's U value has some value here. And strangely enough, all the value is same, so I think something is wrong here. Let's go back to check the col value. Okay, the distance is all 0. That's problematic. So at this point, I still have distance value here. So something must be wrong with this one. Yeah. Okay, I do. Let's see. Okay. So let's go. Let's check the detail value again. So dist min, dist max. And that looks okay. Now this thing is supposed to have some value from 0 to 1 at the dist attributes, but in reality you don't have it, so I think something is wrong here. Let's check if I have got this dist min here. Okay, I do. About this one, dist max. Nope. Okay, so am I missing something here? Let's go back to check the detail. Dist, okay, spell mistake. Sorry for that. It's 1M. Okay, let's go back and check. Alright, looks good. And let's delete, change this to value again and see if each point has different value. Okay, yeah, looks like we have. Now let's go back to the vertex wrangle and check the vertices, and each UV's U value have different values from -1 to 1. Okay. I think I do want the UV's U value to be mapped from 0 to 1, so I have to change some value here at the UV here. So the color value is from -1 to 1, so I'll just use the fit function again, which is from -1 to 1 to and map to 0 to 1. Alright. Now it starts from 0 to 1. Okay, looks good. Now I have got the UVs. Let's just try out by mapping the textures on top of this surface if it looks okay. Now before doing that, let's normalize this. Let's create a normal here and create a quick shader to check the textures. Now I have prepared some test gradation textures for this samples called grad.png, so I'm gonna just use this to check. Okay, now at this point nothing seems to happen. Let's check why. So I do have these UV point here. What if, wait, let's go back top. Okay, now it works. Yeah, sometimes it happens, you have to go back top and go back again to get a new update. I don't know why, I think it's a bug. Okay, so based on the distance value and converted into a sine wave or cosine wave value, I have successfully converted into the UV value, which could be used as a texture mapping value. And also I have implemented some functions that you can control the speed to change the angle of the wave. So if I play it, it will change the UV based on the speed. So let's make it a bit slower. Nice. Okay, I think I should set the speed maximum to 0.1 or something. Also, this is pretty much it for in order to use a distance value to create a marble pattern. And because I have created some other parameters like this offset multiplier, let's also make some ripple patterns on top of this geometry using this similar value, the distance value. Gonna make the maximum of the offset multiple to 10, and what's this? Okay, now in order to create some ripple pattern, I'm just gonna create another wrangle somewhere around maybe the last step. And I'm gonna name this set UV, and I'm gonna make a point wrangle after the set UV, and I'll name this ripple. Okay. Now the thing that I want to do is pretty easy, because I have, if I look at the point wrangle, I have color, distance, and wave, and I'm gonna use this distance. I'm gonna use this wave value, which is from -1 to 1, I think, as a offset value for this surface. So in order to do that, I can just change the position of the point by adding a normal direction times the wave parameters. And also, if you want to control the offset thickness or height of the ripple, then I can add another parameter like offset. Okay, so yeah, by changing this parameter, I can clearly see that I am offsetting the surface, making a ripple pattern. And let's get into the normal. Now, as you can see, it's a bit too big. The ripple is too big right now, so let's change some. Let's promote this offset first to a controller here by opening it in the edit parameter interface, and go back to this ripple. Check off for a bit and drag and drop this offset. And I'm gonna name this offset height or ripple height, maybe. Well, it doesn't matter. And I'm gonna set the maximum to maybe 0.2. Okay, let's go back to the controller and increase this offset multiplier and decrease this height. And now you can see more clearly the ripple patterns on the surface based on the UV or based on the distance from the starting point. And together with the UV textures, you have now a really interesting marble pattern animated, both for textures and geometry. Very interesting, isn't it? Yeah, I think it's pretty interesting. And because it's the UV value has been applied to vertex, you can also export this as, I don't know, like FBX or Alembic to import it into like game engines like Unity or Unreal, to use these UV value directly inside those game engines to use it together with the shaders to make it more interactive or something, to make it more interesting. The strength of the Houdini is that you can also use these values for geometry modification. So that's what I like about this tool. Okay, well, that's it. And that's how you can create a marble pattern using a shortest path node. Find shortest path node. The one I'm explaining in the book, this one, the algorithm design workbook with Houdini, is using the different technique, totally different technique, in order to create a similar marbling pattern. So if you're interested, you can please go buy one copy. Okay, that's it. Thank you again, and see you next time.